Hello everyone, this video presents Humanoid, a deep learning-based approach to automated black box Android app testing. To test an Android app, one has to first generate test inputs by a test input generator. A test input generator is a program that interacts with the app in order to test it. Given an app, the test input generation policy of a test input generator determines the test input sequence generated, and the test input sequence determines the effectiveness, for example, coverage, of the test input generator. Humanoid is a test input generation policy that is learned from human usage traces. Why do we need to learn from human traces? Most existing test input generators apply heuristic random strategy to generate input events. The heuristic random strategies tends to fail in choosing the most efficient path. In contrary, a human knows where to click and what to input, which would probably lead to more coverage in less time. Why do we use deep learning? During using an app, a human decides what to do next according to visual information. Humanoid learns from human, so it does the same thing. That is, given the current UI state of an app, Humanoid should decide what to do next. Deep learning is proved to be successful in dealing with complex inputs like images, so it's adopted by us. This is Humanoid model. The model's input contains UI states and input events. For UI states, UI skeletons instead of raw screenshots are fed into the model. Red blocks represent text regions, and green blocks represent non-text regions. For input events, they're represented by a Gaussian distribution whose center lies on the event's positions. Brighter pixel means higher probability. We consider last four UI states and input events. Because there is no input event for the latest UI state, black pixels are padded. Our model predicts two probabilistic distributions. The first is the probabilistic distribution of input event types. The second is the probabilistic distribution of input position. By multiplying the former two distributions, we get probabilistic distribution of input event candidates. Test input generators then sample from the probabilistic distribution to get the next input event. In the example, touch slide menu button is the most probable choice for next input event. The data set we used to train Humanoid is processed from RICO, a large crowdsourced data set of human interactions. Let's visualize a real training process. This is our training process. Heat map loss indicates the loss for input event position predicting. Interact loss indicates the loss for input event type predicting. You can see both of them goes down during the training. This is our training input UI states. This is our prediction for input event position. This is our ground truth for input event position. You can see our prediction is fitting the ground truth. Next, let's see how Humanoid works on realistic apps. We integrated Humanoid into DroidBot, a lightweight test input generator for Android. First, we start Humanoid service for DroidBot. Next, we start DroidBot specifying Humanoid address. The app under testing is BBC. The brightest area is go to settings. Then the back arrow. Then yes button. Then the news title. Then the advertisement. Thanks for watching. Please refer to our GitHub page for more details.